Hi everyone, this is lesson 2, logarithmic functions review. So we're going to be talking about logs, and logs are related to exponents. So the last lesson we were doing exponential functions, and we had exponential growth, and we had exponential decay. The logarithmic growth and logarithmic decay follow a similar pattern. They both have asymptotes. Exponential functions had horizontal asymptotes, and logarithmic functions have vertical asymptotes. And it's a vertical asymptote at the y-axis, so when x equals 0. Now one thing to note is if you have a base of a logarithm, so the one on the left, the base is 2, and we have logarithmic growth. And the one on the right, we have a fractional base, and we have logarithmic decay. Now if you can think back to exponents, all right, if I have a number that's bigger than 1, and I repeatedly multiply that number, so 2 times 2 gives me 4, and then if I multiply 4 by 2, I get 8, and then if I multiply 8 by 2, I get 16. You'll see that the number is increasing. Okay? If I have a fraction, like 1/2 times 1/2, that gives me 1/4. And then if I multiply 1/4 by 1/2, I get 1/8. And you'll see that this is decreasing. So that's why if we have a number that's bigger than 2, bigger than 1 as our base, you get growth. And if you have a number that's less than 1, you get decay. So let's match these graphs. So two of these are exponential growth. That's exponential growth, and that's exponential decay. So those go with the exponents. So again, look at your base. We've got positive 2 and 0.1. Okay, well the positive 2 has to go with growth, so that's going to be D. And the 0.1 is going to be A. And then we have two logarithmic functions here. We've got log base 2 of x, and we've got log of 1/4. So the number that's bigger than 1 is going to be our growth. So that's got to be B. And the base that is less than 1 is decay. So that's got to be C. Now on your formula sheet, you're given this, the rearranged form of an exponent. And you'll note that the base, A, is still the base of the logarithm. And what you do is you swap positions of the other things. Okay? Let's do the first one here. We get log base 5 of 125 is equal to 3. Okay, the base of the exponent is still the base of the logarithm. This next one is a little bit different because we have this 10 going on. So let's simplify things. And we get x to the 4 is equal to a over 10. Now we can apply the laws, rearranged form. So x is still your base, and that's going to equal 4. This one, let's clean it up a bit using a little bit of algebra. So add 8 to each side, and we get 12 is equal to kx squared. Divide by k. And now we can apply our rearranged form. So log base x of 12 over k is equal to 2. Okay. And let's try another one. We're going to go from logarithmic form to exponential form. So the base of our logarithm is the base of our exponent. And then we switch the other two parts. Let's clean this up a little bit. So divide each side by 2. So 3 is equal to log base x of 125. So base x is still the base of our exponent. And we're going to get x cubed is equal to 125. And you could actually solve this one. So what number cubed would give you 125? And that's going to be 5. So you could actually solve this. All right, one more. We have to clean this up a little bit as well. We have this constant, so let's move that over to that side. And then let's divide by 4 to get rid of that coefficient. And now we have a logarithm with a single argument. Okay, there's no coefficient, there's no constant hanging out. So now we can rearrange this. I'm just going to bring this up here. So we're going to get 2 to the exponent, 16 over 4. I should have cleaned that up a little bit here as well. 16 divided by 4 is just 4. So 2 to the 4 is equal to 8 minus x. All right. So laws of logarithms. If you're adding logs with the same base, that's important, you're going to multiply the arguments. If you're subtracting logs with the same base, you're going to divide the arguments. Okay. This exponent here, you can bring to the front. Okay, that's an important rule. You can switch. You can bring an exponent down or you can put it up depending on what you need to do here. All right, so rewrite each expression as a single logarithm and then evaluate. So we're adding a log and we're subtracting. So the first two get multiplied. So 28 multiplied by 12. And then we're subtracting, so we're going to divide by the third number. And this simplifies to log base 2 of 16. All right. Now, 2 to the x equals 16. Okay, so some number raised to another exponent of x is going to equal 16. And that number has to be 4 because 2 to the 4 equals 16. So this equals 4. Okay. We are subtracting 2 in a row. So we're going to start off base 6 of 2 divided by 9 times 8. And this will simplify to log base 6 of 1 over 36. And that evaluates to negative 2. I guess I should explain how that evaluates to negative 2. So you can do this a couple different ways. One way is to evaluate it on your calculator. And this is calculator method. You can, on your calculator, type in log of 1 over 36 and divide that by log 6. Okay, you'll notice that I don't have a base of 6 anymore. This is called a change of base formula, and that'll give you negative 2. The other way to think about this one is the base of 6 to some exponent is equal to 1 over 36. Now 36 is the same as 6 squared, so we can kind of go like this. And then there's an exponent rule that says if we have 1 over x squared or cubed or whatever, that's the same as x to the negative 2 or negative 3 or negative 4. So 6 to the x is equal to 6 to the negative 2. Now you'll notice that these are equivalent forms, same base, so x must equal negative 2. Okay, we're adding 2 and subtracting 1, so the 2 that are being added, the two logarithms, we're going to multiply those two numbers. And the one that we're dividing, you're going to get 105. And if you simplify that, you're going to get log base 2 of 2. And again, if you think about this, this has to equal something. So if we rearrange this, you get 2 to the x is equal to 2. Well, what does that x have to be? It has to be 1. So that's the only way that 2 is going to equal 2. So log base 2 of 2 must equal 1. Okay, we had talked about coefficients and how you can bring them up and make them exponents here. So we're going to get log base 4 of 2 to the 8 plus log base 4 of 1/8 squared. So cleaning it up a little bit here, 2 to the 8 multiplied by 1/8 squared. We can get it to a single logarithm. And then if you type that into your calculator, 2 to the 8 multiplied by 1/8 squared, you actually get log base 4 of 4. And from before, if you have the same base as the argument, this must simplify to 1. Any of these examples, if you need to watch them again, just pause and rewind. Okay, let's bring these exponents up. Okay, so log 5 cubed plus log 2 cubed minus log 10. As a single logarithm is going to be 5 cubed multiplied by 2 cubed divided by 10. And that simplifies to log 100. And log 100 you can actually type in your calculator. If there's no base written, the default base is 10. So log of 100 actually simplifies to 2. Because if the base is 10 there, this means you're going to have 10 to some exponent is equal to 100. Well, that exponent has to equal 2. So your answer here is 2. All right, getting a little bit more complicated. First of all, let's bring up our coefficients and make them exponents. And you can actually evaluate 16 to the half and 8 to the 1/3. Okay, so we get log base 4 of 4 plus log 4 of 2. Now, log base 4 of 4 just simplifies to 1. This part here is a little bit trickier to think about. So let's do a little sidebar. Log 4 of 2. Now, if you're ever wondering, well, how do I solve what that actually is? Let's set it equal to x. Rearranging this must mean 4 to the x is equal to 2. Well, what exponent is going to get me from 4 to 2? And that's the same thing as the square root of 4 is 2. And the square root is the same as half. So our exponent, or what that simplifies to, must equal 1/2. So our simplified answer here is going to be 1/2, or you could write that as 3 over 2. Let's start by bringing up our coefficients and making them exponents here. And this will become log of 16 minus log of 2 to the 4. You can have that backwards actually. 2 to the 4. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So this becomes log base x of 16. All right, so log base x of 16. Subtracting, so we're going to go 16 over 16, and that simplifies to just log base x of 1. So evaluating this, if we can think about this, we're going to go x to the x, or give it some other value here. So x to the y is equal to 1. Well, what exponent do we need to put in to make this simplify to 1? And if you recall, the 0 exponent, anything to the 0 exponent simplifies to 1. Okay, 100 to 0 is still 1. So this must equal 0. Because if you rearrange, x to the 0 equals 1. All right. We're going to increase the difficulty level here a little bit. Right, as a single logarithm, and then we're going to do some substitutions. This part's a little bit key here. We've got to substitute. All right, so we get log base a of x to the half plus log base a of x cubed minus log base a of x squared. All right, now we have log base a of x, log base a of x, and log base a of x. And over here, we're told that x is equal to a to the power of 4. So let's substitute a4 for x. So the first one becomes log base a of a fourth, and you still have an exponent of half, plus log base a of a4 cubed minus log base a of a4 squared. Now just to review, power of a power rule says if we have a to the m raised to another power, we're going to multiply those two exponents. So we're going to do the same thing here. Log base a of a squared plus log base a of a 12 minus log base a of a 8. Okay. And from here, we're going to get 2 times 1 plus 12 times 1 minus 8 times 1, just bringing down those exponents. And log base a of a in each case equals 1. So this simplifies to 2 plus 12 minus 8. So 14 minus 8 gives me 6. Okay. I suppose you could have done the substitution at the beginning and just substitute in a4 right away. There's multiple ways to solve these. Okay, so we got x is equal to a4, y is equal to a negative 1. So let's do some substitution first and just see where we get to. So x is equal to a4, so we're going to get a4 cubed multiplied by a negative 1 to the 4th power. And let's clean this one up. So a 12 multiplied by a negative 4. And you're going to get a 8 if we add those two exponents. And then we can bring down the 8. So the first part here is going to become 2 multiplied by 8 multiplied by log a. All right? And that simplifies to 16 times 1. Now let's do this second part here. Okay? Substituting in a4 for x and a negative 1 for y, we get minus 3 log base a4 multiplied by a negative 1, and this is going to become log base a of a cubed. And then we can bring down this exponent. Get minus 3 times 3 times log a of a, which becomes minus 9 times 1, so you get minus 9. All right, and the last one. Let's simplify again. So plus 1/4 log a, and substituting in a4 for x, you get a4 to the 4th power, and a negative 1 to the 8th power. That becomes a 16 multiplied by a negative 8. And we get log base a of a 8. Bring down your exponent. It's being multiplied, so multiply by 1/4. And so finally, 1/4 times 8 is plus 2 times 1. All right, so we've simplified each part, and you get 16 minus 9 plus 2 is going to be 9. All right, expanding the following logarithmic expressions. we have two things being divided. So if we separate this into two logs, that means you subtract the two. We're multiplying, so if we separate this into different logs, we get log 4k plus log 11. Okay? Multiplied parts in the argument mean that you are adding the two separate logarithms. All right, here we have three parts, a, the b4, and the c squared. The a and the b4 are being multiplied, so we can add those two logarithms. So log of a plus log of b4. And we're dividing by c squared, so that means you would subtract log c squared. Again, we have three parts, the c cubed, the a4, and the root b. So separating that into separate logarithms, start with your numerator, and you're going to subtract the other two. Now cleaning this up or rearranging form, you could write it like this, where you bring down your exponents. Okay. I made a little jump here. Root b is the same as b to the half. So if you're going to bring down the exponent, it's a half. So that's where this half comes from. It's the root. All right, so we're going to rearrange and substitute. So let's rearrange this part. So we're going to get log 2 of 32 plus log 2 of x cubed minus log y squared. And that's still base 2. All right, 32. We can change 32 to base 2. Okay, so log 2 of 2, what is 2 to the 4 is 16, so 2 to the 5 is 32. Okay, and that will become 5 log 2 of 2, which simplifies to 5 times 1. Okay, so that's the first part done. And then let's bring down that exponent. And let's bring down that exponent. The reason I'm doing that is in the information we're told what log 2y is, not what log 2y with some exponent is. Okay, so I'm getting rid of or changing where the exponent is. So 4 is equal to log 2 of x, so we can substitute that in here. And 7 is equal to log 2 of y. So we can substitute that. So you end up with 5 plus 12 minus 14, which is 3. All right, another substitution question. Let's split this logarithm into its separate parts. Minus log base a of a5 minus log base a of the cube root of x. All right, so a couple things here. I can see that this log base a of a is going to simplify to something nice. We do need to change this cube root of x into an exponent. So let's do that. Cube root of anything is the same as that to the 1/3. So we're going to do a few steps here. First one is we're going to drop that exponent. Okay. And we're going to do the same thing here. And the last one, we're going to just rearrange this to x to the 1/3. Okay. Now log base a of y is -2. So this is going to be 4 times -2 minus 5 times 1 minus 1/3 times x, or times 6. So -8 minus 5 minus 2 becomes -15. If x equals log 2 of 5 and y equals log 2 of 3, express log 600. So the first thing I'm going to do is prime factor 600 in this case. I want to rearrange 600 into terms of log of 3 and 5. Okay, so prime factoring 600. If you can't remember how to prime factor, you got to look up and try a couple of these. Okay, so 600 prime factors to 2 cubed multiplied by 3 multiplied by 5 squared. So we're going to substitute that in for 600 here. So log base 2 of 600 is equal to log base 2 of 2 cubed multiplied by 3 multiplied by 5 squared. So we're multiplying arguments. So we can separate this into 3 separate logarithms that are being added. Okay. Now we can do some substitution if we want. X is equal to log 2 of 5. So log 2 of 5, that becomes x squared. Log 2 of 3 is y, so that simply just becomes y. And log 2 of 2 cubed, we bring that exponent to the front, and log 2 of 2 is 1. So this will simplify to 3 plus y plus x squared. Made a mistake here. I'm going to bring this exponent down. That should have been 2x. There we go, 2x. Okay. One more substitution here. Let's prime factor 360. All right, so that becomes 2 cubed multiplied by 3 squared multiplied by 5. So again, let's substitute that information here. So log base 2 of 2 cubed multiplied by 3 squared multiplied by 5. And that becomes 3 separate logarithms. And because we're multiplying the arguments here, when you separate the logs, it becomes addition. All right, let's bring those exponents and make them coefficients. And now do our substitution. We're told that log 2 of 5 is m, so that just becomes m there. Log 2 of 3 is n, so we can substitute that, but it's being multiplied by 2. And then this part becomes 3 times 1. So it simplifies to 3 plus 2n plus m. Okay. I'm going to skip the next one. It's very similar to the one we just did. And that's it.